Hello, everyone. So, throughout the past few months, I've built several workflows for creating AI video scenes. And from the start, I remember like a few months ago, I began using a workflow to build character images with consistent faces, and then we used that. At the time, there was no Flux yet. It was using SDXL and IP adapters with large language models. We also used consistent character images, running them through Reactor to build face models. We even had Alora training those characters. Afterward, I moved on to something like a pretty complex workflow using SDXL to build several images prepared for AI videos, each scene running image to video. Through experiments, trial, and error, things kept improving. I remember building this in 4 steps of workflow. In one process, I used Clean AI to do image to video animations for those scenes. And right now, as we have Flux, as you can see, I did it previously. Recently, I've come back to using Clean AI more often because I'm doing some work and playing around with new features. I've got some creative things going on, and I'm trying out what they've got. Also, with Flux, we've got Flux Redux, which enables us to get better, more controllable results on the styles we want for our characters, backgrounds, or any elements in our video scenes. I create short movies or video stories just to test concepts and see how they work. I've posted all of that on YouTube Shorts as well. I've been trying out those animations, seeing how they perform with different effects. Some use image to video, which is very commonly used in AI videos. Right now, where I build each image, like this one, the girl holding this mystery box, she gets some power, and there's a blade with flame-like energy. We've also got some concepts bringing outfits from Mortal Kombat, making my own characters like this. I'm trying to push the edge of AI video animations, seeing how far AI videos can go in rendering action movements, especially fight scene styles like Mortal Kombat. Although some of the movements are kind of morphing, we can still get some exciting effects. Lightning, power energies, and broken body parts that feel pretty fitting for fight scenes. Like when someone punches and tries to break part of the opponent, scenes like that. Although some quality can still be improved, most scenes, like in this one, are getting crazier. I didn't use any Flux here, instead I used the Japanese-style sword for these female warriors practicing their blades. It's one of the videos I mentioned using the new image generation model, Lumina Image 2.0. This base model is pretty nice. You can just use text to image, where I generate all these scenes with the same style. Well, although this isn't from the AI video scenes image generation workflow I'm using, the base model is quite impressive. Going back to video scenes, building consistent style characters isn't an issue anymore with Flux. We've also got environments, backgrounds, and effects able to build another world in these movie stories. I've updated the workflow I was using previously. Actually, I rebuilt the whole thing from those 4 separate workflow files. Now I'm using just one workflow like this to create each image scene. Of course, you'll need character Laura, which I mentioned in previous videos. Most of my characters are using Flux Gym to retrain the images I generated when I first started my workflow for characters, bringing them to the Laura trainer. Because of that, I can use each character's face without needing face swaps, avoiding unusual facial expressions or edges on the side of the face. Therefore, I'm using this workflow I'm showing right now. Basically, I've got a loader, and then I add those Lauras in here, where I can make or build the whole image scenery by going through details. For example here, I've got another example where I generated a ninja guy standing on top of a building rooftop. The style is like Assassin's Creed, you know? Just run this and you'll see how that looks. So, coming back to here, we've got the image. As you can see, this is a very basic text-to-image step where I haven't enabled other features in this workflow. Starting from here, I've marked by numbers from 1 to 5, doing it step by step. Now, of course, the first step enables number 1, and we're generating text-to-image. Or you can use image-to-image if you prefer. All you have to do is modify this latent image input, loading your own image for image-to-image. But if you're experienced in making AI videos, you'll generate tons of image scenes for the image-to-video process. There's no time to waste finding the right image for image-to-image processing. Most of the time, we'll use text-to-image to build the scenes we want, like in Flux. The prompt following is pretty good. We can overcome some problems with character or background positioning on the image canvas. For example, I'll choose something like this image. It's good for what I want to do. Let's say I want to move to step 2, and I'd like to use the copy clip space feature. We all have that in ComfyUI, a very basic principal feature. Then, copy this image and I'll go to step 2, which uses Redux to build our character outfit or any particular elements on this image. This workflow may look big, but actually each feature is simple. It divides each image step by step, allowing me to streamline like water flowing down, ending with upscaling. So for Redux, basically as you can see in my previous image here, do masking and apply Redux to this character. For example, this new image I pasted in here. You can use the mask editor. I think many of you already have this experience. For example, like this black-colored ninja suit. I don't want this ninja suit. Maybe I've predefined my character already, and I can use what I have in my existing character image. Therefore, I'll mask this outfit. Once I decide what I want to cover up in the masking area, I move to the next step, which is finding my character's outfit. So you'll go up here, where there's the Redux Character 1 build. I intended to build multiple Redux groups here, so this is called Character 1. But then I found out that we can bring it back after generating the image from this image preview node. Duplicating the same process using copy clip space, then pasting that image back into the load image panel here. We keep doing the masking area for Redux styling. For example, I've got this image as my outfit reference. I want my character to look similar to that while standing on top of the building. So I put that file path in here, then start generating one more time for image generation. Here, we'll have the masking area to adjust our character's outfit. As you can see, I'm showing this image preview in this panel, making it easier for us to know what's running right now, what Redux is doing. After generating the image result, we get something like this, which looks pretty cool. It resembles the reference image I have here, but the texture and elements blend into this hyper-realistic style image, not looking too 3D or cartoonish like the reference image. That's the beauty of Flux Redux. It helps restyle the texture, the elements, blending from the reference image into your masked image. Once I have this looking okay, not top-notch quality, but it works as an example, I can keep duplicating my process, copying, and moving to the next step, which is duplicating the face. But in this case, since I've got this character using a ninja mask, I don't need to do a face swap. If you have scenarios where you want to show the face, like this image I generated previously, you'll mask this area. Let's clear this. If you want to mask the face of this character and switch over to your predefined character face, a reference image, you can do that using the Ace Portrait LoRa model. This whole section here, as you can see, I've labeled all the groups here as Ace Create Canvas. Then this is step 3, the Ace Portrait for face change. In this part here, if I'm using this image, this red female ninja as an example, I'll run this one time and you'll see how that looks. So we've got the result generated using Ace for Portrait LoRa. Basically, I covered this workflow in a previous tutorial about Ace LoRa, and I've also done other versions of this workflow using Pulid. In this version I'm using, it's the Flux Pulid model for face swap. In some cases, I'll use this. In others, I'll use Ace. Because with Ace, for scenarios like the face mask, if I have the ninja guy here with the face mask or the female ninja I showed earlier with the black face mask, if I use Ace LoRa, it will only use a very simple method, changing the whole face from my reference image as an in-context style, blending it over the mask area I have. The result comes out with the character having no mask. But then, with Flux Pulid, I find out it could change the face of the character even if I have the mask on in the base image like this one. Of course, this workflow from Pulid is in this section. We're only using one character at this time, so we're bypassing the second applied Flux Pulid nodes. In this group, we've got the result after processing the Pulids, which you can see. This model is smart enough to just change the face structure, like the eyes of this girl, this female ninja, using my reference image here, and it's also smart enough to keep the face mask of this ninja black mask on top of the character. That's the difference between these two methods. Well, some people in the beginning, when Flux Ace LoRa launched, hyped it up, thinking it was the best method for consistent characters on the market right now. But then, I put critical thinking into analyzing this in my previous videos. Right now, I can prove that in some cases, using Ace isn't always the best way, because Ace transfers what you have in your reference image as an in-context style, sticking it on top of your base image. Therefore, it always needs two images combined in a canvas like this to let the context from the LoRa work. On the other hand, with Pulid, you're also masking the area, but they have their own AI models using Pulid. So here, it's using its own Pulid for Flux version 0, 9.1 with the Insight face. It also has its own Flux clip model to process that. Therefore, in some cases, I prefer using Pulid rather than ACE. Plus, if you have something like this, I've got a character with a mask on, you don't want this ninja to be nonsense, removing the mask in public areas, right? So therefore, we need that black mask to stay on the ninja. In this case, I'd prefer using Flux Pulid like that. So I've got these two workflows almost the same, but only in this section, number 3, I've got both different methods, Flux Pulid and also Flux Ace Plus for the face change steps. That's the difference in step 3. After you've got, for example, we're going to enable step 4, which is refiner. Mostly, the refiner and upscalers can run together in one generation process. Sometimes I'll set back to step 3 here in the ACE. Sometimes you want to disable this sampler group because it's using random seed numbers to generate each time. I found out that Flux Ace is still not stable, as they've already mentioned on their official Hugging Face page. This LoRa model is still in development, so I sometimes have to generate a few images to get the one I want. It is what it is. So, if you've got an image like this case, I want to bring it to the next step. Actually, the refiner doesn't need to use clip space because it's already in one pipeline. I'm using the get and set node here. For example, if I've got the image I want, maybe I want to generate one more time to have a better face. Sometimes when it's switching the face, it looks a little awkward. Even for Ace LoRa with objects, subjects in context merging, it can look a bit awkward in the generated result. So I'll mostly use random seed numbers or have a fixed seed number, keeping changing the numbers on top to try different varieties of styles and see how that generates. For example, after I generate this one, you see it's a little different sometimes. Let's say I've got this image that I want to bring to the next step, which will be the refiner. And for the refiner, we mostly combine it with upscalers, because in the refiner, we don't need to edit anything in this group. It's just another Flux sampling group to enhance the image here. Also, I've got the get and set node for this group. If you don't need to do the face swap step in step 3, you can just, after clothing and outfit change in Redux, use image 2 to get this value. Coming back to the top here. In step 2, after we change the outfit of the character, masking that using Redux, we've got this value passing to the image set nodes here, which is the image we're showing in this image preview node. So passing this value here, you can directly skip step 3 if you don't need to do a face change in this part. Let's say I still want to refine this red color ninja woman image. Then, I can go back to select the image face final, the image ace face final. This is the value passed from the Flux Ace face portrait image processing. So after this processing, we pass that to here. It will be doing step 4, another sampling refinement for the image. But this time, this isn't the first text to image in step 1 or step 2. We're refining step 3, the after face swap image. And there you have it. While I'm talking, it's done. Lastly, it brings us to step 5, which is upscaling. The most important part will be the styles of the outfit or the styles of the backgrounds that you want your AI videos to present. If you're using image to video, you want to change the background, you can do that with the mask highlighted on this part as well. Or if you want to change the character outfit, like in this case, you'll highlight the mask area on the character outfit. Lastly, we'll do the upscaler. Nothing you need to configure here. It helps you do the math calculations already. I've set the math expressions to set the width and height, multiplying by the numbers of settings you want in the upscaling process. By default, I set this to 2, so 2 times upscaling from the refiner images. That's the final result here, and as you can see, when I've got this image comparison node, you can see some differences. Where we've got more detail after upscaling, it's even more detailed than the refiner group. Something like, especially like in this case, we've got the ninja. We've got some leather belts and pens where we've got the leather belt showing the mark of the leather straps. And also the arms here, we've got some decorations like snake skins wrapping around our arms. Something like that is going to show. Yeah, so this is how we can do that. Also with Pulid, the way of using Pulid is going to be the same way. When I want to continue with this image after doing the face swap or face change, whatever name you want to call that, you can enable number 4 and 5, which is refiner and upscaler, and run that again for the next process. And there you go. We've got the result of the refiner group and the upscale group. As you can see, this comparison is compared with the refiner group's output image here. Pass that to the upscalers, and we've got the upscalers compared with the refiner image. You see it's even better enhanced after using the upscale model and using the Ultimate SD upscale nodes to process the image upscaling. We've got sharper eyes, a sharper mask as well. The mask is even better in this part. Also, we've got the leather strap. I play around with the ninja suit a lot. I like to check out if there's some leather strap like this one able to shine it up. And even below here, we've got those pens allowing us to have that leather. Even the leather belt right now, we've got some pretty detailed texture on top of that. So we've got the difference between using Flux Pullet and also Flux Ace for face swap. Two images are going to look well. The same structure of the image, but then we've got the face looking different here, and a little bit difference also on the texture of the outfit. Something will be affected there. So yeah, I'll be using both of those parallel. I'm not going to stick with just one face swap method. After I find out that something even works more advanced than just a simple face swap like this, I can even have a mask on the face. Or if you have AI videos, maybe your character has a scar on top of the face or has a blind eye like a pirate captain, something like that, that will also remain those eye covers or the scar of the face, doing the face swap for the face structure, the eyes, nose, all the things following from your reference image. So this is throughout my experiments of making this workflow, and I found out a big difference between two face swap methods here. Yes, but sometimes we'll use either one to make the video scenes like that. It will be very detailed, showing how detailed you are. If you make this kind of little difference in your AI videos just like this, you can represent how the character looks like without, not too detailed. It's just generally a face swap. It will just make the character look pretty mediocre in output. Yeah, that's the way it is. And as I mentioned, if you don't need to do a face swap like in this workflow here, after you've got the male ninja like this, you've got the outfit good enough to continue. Of course, you can bypass step 3 and those ace groups, going to the refiner, which will select image 2 for this set image here as the input for the image-to-image refinement group here. We select image 2, and then we can continue to do another image processing here. So after we've done the refinement for this white armor suit ninja, we've got the upscale output generated result here, and we've got the generated result. So let's bring this to animations, which everyone's going to get hyped and pay attention to. So I'm going to use Clean AI as an example because I've got those credits to play around with. For example, I built this scene before with this image. Basically, this is 3 sections. One is the character outfits. We've got 2 character outfits with 2 different faces, and also the background. This is the structure of how this image forms. I'm using the same workflow as what I've just shown here, and just put that as an image to video. And basically, you do some prompting, do some video effects, how you want to animate that video within the durations here. Like for example, I light up this energy on this character, and then the other half of 5 seconds, I light up this energy on the purple ninja. The cool thing about Clean AI is something out of this workflow topic, which is the element where I showed this in previous videos about Clean AI updates. But then I'm also just using this image as a reference and only cropping this area as these characters focusing us on one of the elements in this video scene. So therefore, I've got 2 characters cropped in this element section and then upload another background image as the fighting scene here. And it looks pretty nice. I was trying to push the boundary of AI videos, seeing how capable it can be for fight scenes and action movements like that. At least Clean AI can handle like 60% of that right now, something I expected. And then I just tried to animate those images I showed at the beginning of this video, which is this ninja practicing image as a scene, bringing it to Clean AI to try that as well. As you can see, this image looks okay in this generation, but then at the end of this, it just this last 3 seconds here, the character's eyes are out of focus, not looking anywhere at the opponent. Well, if we put this video into AI stories, then maybe we have to cut this last 3 seconds, remaining this first 5, which is pretty good in this part. And the second example, which is this one, looks good on the first half of this video. But then the other last 2 seconds here start touching each other's hands, and then the fingers kind of start getting messy with 6, 5, 6, 10 fingers on the hand like this. But yeah, if we use AI videos in clean AI like this, mostly for me, I'll cut those durations that look bad and remain those that are good. Like maybe I'll cut to here and then it will switch to another scene, etc. So you get the idea. And this one looks kind of awkward and they are holding hands. But then actually, I was asking for a point practicing martial art. Well, sometimes AI will show something weird. And this is the red outfit ninja that I just generated, bringing that into clean AI for the video scene. It does perform things that I expected, jumping to another building like the style of Assassin's Creed. So therefore, I did this prompt here in the text prompt. And the other two examples don't look good. This one looks awkward. Like when it jumps, it should be, Assassin's Creed, those jumping from the top, following up the character, the camera following the character back view and jumping down. But then this one doesn't do what I expected. And then the other example here does something like this, but then it just flies off in the air. So therefore, maybe this kind of too aggressive action in AI video still couldn't do that. Maybe they censor this kind of dangerous act or they haven't trained those data sets like a stun move in action movies. Who knows, right? We haven't seen what their data set is, so we can't judge that. But still, we can say there are some actions like this stun move that aren't pretty follow through with what I expected. So this workflow is built for creating AI videos for image-to-video scenes. We can have more control over the character's outfit. Also, some actions we can do that in control. Actually, as the conclusion of recent updates in AI videos for some poses and actions, I don't actually focus too much on the image generation part because we can do that in AI videos right now, like Clean AI and Minimax, other AI video generators. They can do it by using the first frames and doing text prompts, follow through with what's happening with the character right now, doing some text prompts to try to do some actions on the video scenes. So I didn't really focus too much in this workflow on dealing with the character pose, except I'm more focused on the environment, how that looks like, or the character outfit. Also, the face swap. How can we make it more natural? Not just like sometimes reactor face swap. If you guys use that or some older face swap methods, it feels like copy pasting the face on top of the base image. So right now we've got some improvement with face swap using Flux Ace Plus and also Flux Pulled, especially Pulled. I liked it when I discovered it's able to face swap even if the face has a mask on. And this proves that if we have a character like a pirate that has one eye covered with an eye patch, or you've got a man with a scar on the face, maybe you can have those special identities on the face remaining, but then the face structure is going to change based on our reference image here. So yeah, that's what I found out, and I'll be using both methods for face swap. Hope this inspires you guys to make your own way of creating workflows for your AI video scenes. Or you can use this concept to do that as well. I'll publish the basic version of this workflow for beginners since a lot of features and things are going on here. Lots of things are going on, and I believe not all beginners are able to understand it. So I'll make it simpler, allowing people to play around with it, just trying to make it as simple as possible in this beginner version of the workflow. And you guys, everyone, can download that as freebies, and I'll see you guys in the next video. Have a nice day. See ya.